Experiments have demonstrated that ocean acidification as a result of elevated carbon dioxide in the atmosphere has a detrimental effect on the performance of many marine organisms. In this study, the authors, Fabricius et al., examined the long-term effects of ocean acidification on marine ecosystems. By examining coral reef, seagrass, and sediments at shallow volcanic carbon dioxide seeps in Milne Bay, Papua New Guinea, the study indicates that as pH level declines, so does the coral diversity and recruitment of new coral. Also, a reduction in structurally complex framework builders and a shift in the competitive interaction between taxa. Coral communities at 3 meters in depth were compared between the control sites of low carbon dioxide seeps greater than 5 meters from the transect line and high carbon dioxide seeps less than 5 meters from the transect lines. A low carbon dioxide site constitutes a pH range of 7.97 to 8.14. A high carbon dioxide site has a pH range of 7.73 to 8.0. Sites of intense carbon dioxide streams with a pH of less than 7.70 were excluded from the study, as no reef development was observed.
As you can see in Figure A, hard coral cover has remained fairly constant. However, there has been a significant reduction in the richness of taxonomic species, these being the more structurally complex hard corals. Conversely, less structurally complex, massive porite coral has doubled in cover, accounting for the overall consistency of hard coral cover. The results in Figure B show reductions in all juvenile hard coral density and richness. The results for soft corals show more dramatic decline associated with elevated CO2. Juvenile soft coral species have an 18-fold reduction in density and a 12-fold reduction in species richness. Figure D represents seagrass communities found at the sites. Both density and root biomass has increased overall by 3 to 4 times at elevated CO2 sites. However, as seen with coral communities, species richness and diversity has decreased. Carbonate organisms and epiphytes living on the leaves of the seagrass communities were reduced almost to zero in close proximity to the CO2 seeps. Surface sediments were also analysed. As you can see, significantly reduced organic carbon and calcareous biota and their remains at the high carbon dioxide sites. The data presented by Fabricius et al. Is conclusive that as seawater pH decreases to 7.78, coral ecosystems can still exist, however with a severe decline in biodiversity and structural complexity. This paper contributes to the burgeoning wealth of studies investigating ocean acidification and the effect on calcifying organisms and their communities.